The next question is, there will be three vectors are given, A vector, B vector, C vector. And also whose modulus values are there. Modulus A is 3, modulus B vector 4, modulus C vector is 5. And each one of them being perpendicular to the sum of other two. So these are the important given data. Each one of them, out of these three, one vector being perpendicular to the sum of the other. That is, one vector is perpendicular to the sum of other two vectors. That means A vector is perpendicular to the sum of B and C, or B vector is perpendicular to the sum of C and A, or C vector is perpendicular to the sum of A and B. These are the data are given. Then what is the value of this modulus A vector plus B vector plus C vector? This value is already given. Now using this var, we write in symbol. Given each one of them being perpendicular to the sum of other two. Especially A vector is perpendicular to B vector is perpendicular to is not given. One vector is perpendicular to the sum of other two vectors. So I write by the given data, A vector, that is one vector, is perpendicular to the sum of other two. What are the other two vectors? We already write A vector. The other two vectors are B vector and C vector. A vector is perpendicular to the sum of B vector and C vector is a given data. You know very well, when two vectors are perpendicular, then whose dot product value should come 0. So A vector dot B vector plus C vector is equal to 0. We are using the result. So first one, A vector is perpendicular to B vector plus C vector, therefore A vector dot B plus C is equal to 0. Next one, B vector is perpendicular to the sum of other two. What are the other two? C and A. So B vector is perpendicular to the sum of C vector plus A vector, or we write it is A vector plus C vector. So B vector is perpendicular to C plus A. Here also we see these two vectors are perpendicular. When two vectors are perpendicular, then whose dot product value become 0. Therefore, the dot product of B vector and C vector plus A vector is equal to 0. So this is the sum of two vector. So we write either A vector plus C vector or C vector plus A vector. Also, C vector is perpendicular to the sum of other two. What are the other two? A and B. A vector plus B vector. So these two vectors are perpendicular. Therefore, C vector dot A vector plus B vector is equal to 0. So we are using all these results. So first, we find this according to our given data, we do some values. The dot product of these values are 0. The dot product of A dot B plus C and B dot C plus A and C dot A plus B is 0. Now we find modulus A vector plus B vector plus C vector. So now we will take modulus A vector plus B vector plus C vector. We find that value. First I find whose square value. I will write A vector plus modulus A vector plus B vector plus C vector as modulus A vector plus modulus B vector plus modulus C vector the whole square. I write it is A vector plus B vector plus C vector the whole square also. You know, in a vector square, how to write A vector plus B vector plus C vector the square? We write it is LHS is same. No change. In RHS, we write it is A vector plus B vector plus C vector dot. Again, A vector plus B vector plus C vector. You know, in vector, we write A square as A vector dot A vector. So, A vector plus B vector plus C vector square as A vector plus B vector plus C vector dot. Again, A vector plus B vector plus C vector. Now, each vector is taking dot product with the other vectors. First of all, I write this A vector is a dot product with this three vector. A vector plus B vector plus C vector. The next one is a B vector. So if we take the dot product with the B vector with the same A vector plus B vector plus C vector plus, what is the third one? C vector. C vector dot A vector plus B vector plus C vector. Because all this dot value is already fine. So the next step is taking dot product. The next step is your choice. We taking dot product with each and every vector. Or we already see some results. What are the results? The value of A dot B vector plus C vector is 0. The value of B vector dot C vector plus A vector is 0. The value of C vector dot A vector plus B vector is 0. So using the result, I split this dot product values. The next step, this A vector, first of all, dot product with this A vector plus this A vector is a dot product with the sum of the other two vectors. B vector plus C vector. What is the reason to write at a time? We already know that value vanishes 0 plus here also. So what is the first step? I will be taking the B vector dot product with the same vector B vector. B vector dot B vector plus B vector dot B vector. What are the remaining two vectors? A vector and C vector. So I do B vector dot, we write A vector plus C vector or C vector plus A vector plus now the C vector. First taking dot product with the same vector. What is the outside vector here? C vector. Taking a C vector dot product with the same vector. So C vector dot C vector is 1. What is the remaining 2? Sum of A vector plus B vector. C vector dot A vector plus B vector. What is the value of A vector dot A vector? The value is 1. That value is not 1. Why? The dot product of I cap and I cap is 1. Because I cap is the unit vector. But A vector is not a unit vector. In the sum, you see the sum. A vector, B vector is not given in unit vector. Suppose these vectors are unit vector whose value is 1. Then what is the value of A vector dot A vector? We already see in the sum. The value of A vector dot A vector, we write it is A vector square or modulus A vector square or just A square. We write any manner. So I write first of all it is A vector square plus the value of this, that and the last one. All value become vanish. We already find that value. So 0 plus, we write a B vector dot B vector as B vector square plus that value is 0 plus C vector dot C vector, C vector square plus The value of C vector dot A vector plus B vector, that value is 0, vanish. So we leave all the zeros because some terms, some zeros are involved. We leave all the zeros. We write A vector square as modulus A vector square plus B vector square as modulus B vector square and C vector square as modulus C vector square. Now you see modulus A, modulus B, modulus C value is also there. We are using the value. You see what is the value of modulus A? Is 3. Modulus B vector 4. Modulus C vector is 5. Now we are using this value here. So modulus A vector square, the value of modulus A is 3 square. The value of modulus B 4 square. The value of modulus C is 5 is given. So 5. So modulus A is given 3, but square is there. So 3 square. Modulus B is 4, so 4 square. Modulus C value is given 5, but all the modulus involved is square, so square. The next step, squaring number. The value of 3 square, 4 square and 5 square. 3 square is 9, 4 square is 16 and 5 square is 25. What is the sum of all value? 9 plus 16 is 25 plus 25. 25 plus 25 is 50. So the value of modulus A vector plus B vector plus C vector, the whole square is equal to 50. But it is not our required answer, because to find modulus A vector plus B vector plus C vector only, we find the square value. So what is the next step? Taking square root on both sides, we get modulus A vector plus B vector plus C vector is equal to root 50. I will be taking a positive square root. I don't put plus or minus here. Why? Because all the modulus magnitude value is always only positive, it's not negative. Therefore it has plus root 50. Suppose the modulus is not involved, we put plus or minus here. In LHS, modulus value is there. The value of modulus is always, very well, positive, plus. So it is root 50. We write root 50 as 25 2s. Because the value of root 25 is exactly 5. So I split 50 as 25, 2. Root 25 into root 2. The value of root 25 is exactly 5 and root 2. So the value of modulus A vector plus B vector plus C vector is equal to 5 root 2. Is important, you don't put plus or minus. The magnitude or modulus value is always positive. The next question is, find the projection of the vector I cap plus 3j cap plus 7k cap on the vector 2i cap plus 6j cap plus 3k. The projection formula. We already write the formula. The projection of A vector on B vector is A vector dot B vector divided by B vector. That is modulus B vector. Suppose the projection of B vector on A vector, same, B vector dot A vector or A vector dot B vector divided by modulus A vector. You see, there is no vector name, that is A vector, B vector is not given. So we take the name of the vector. First, we find the projection of this vector. We will take the vector name is A vector. The value of A vector, I cap, 3j cap plus 7k cap. And the value of on the vector will be take it is B vector. So the value of B vector, 2i cap, 6j cap plus 3k cap. Next we write the formula. The projection of A vector on B vector. The formula is, the numerator is the dot product of these two vectors. That is A vector dot B vector. Divided by, what is the on vector here? On the vector value is B vector. So divided by modulus B vector. So it is a projection of A vector on B vector. So on the vector lies in denominator modulus. The projection of suppose B vector on A vector, numerator same because dot product is commutative. A vector dot B vector is also is equal to B vector dot A vector. Divided by on A vector is suppose given, the denominator is modulus A vector. But here find the projection of A vector on B vector. So we write A vector dot B vector divided by modulus B vector. Now to find the dot product of these two vector in numerator. So what is the numerator? A vector dot B vector. So you write the value of A vector. The value of A vector, I cap, 3j cap, 7k cap, dot B vector, 2I cap plus 6j cap plus 3k cap, whole divided by modulus B vector, modulus 2I cap, 6j cap plus 3k cap. In numerator to find whose dot product and denominator taking modulus. Numerator, we multiply the coefficient of I cap, j cap and k cap because I dot I, j dot j and k dot k caps all values are 1 and all the remaining are 0. So here 1 coefficient of I cap. In second vector coefficient of I cap 2 plus coefficient of j cap 3, here 6 plus coefficient of k cap 7 and here 3 divided by taking a modulus, so taking square root, coefficient of I cap 2, so square 2 square, j cap 6 square, k cap 3 square, 1 2 are 2, 3 6 are 18 and 7 3 are 21 divided by within a square root 4 plus 36 plus 9. In numerator we get 22 plus 18, 20 plus 21 is 41 divided by square root of 4 plus 36, 40, 40 plus 9 is 49. You know very well the value of root 49 is 41 divided by the value of root 49 is exactly 7. Therefore, the projection of A vector on B vector value is 41 divided by 7. Suppose if you cancel, if possible, numerator in our table we cancel. Or it is impossible in both in different table. I don't put in decimal number or decimal form. So I leave as it is. So the projection of A vector on B vector value is 41 divided by 7. Okay, the next question is find a lambda. To find the value of a lambda, when the projection of, you see the name of the vector is also given. The projection of A vector, lambda I cap plus j cap plus 4k cap on B vector is equal to 2I cap plus 6j cap plus 3k cap is 4 units. Suppose the projection of this A vector on B vector value is 4 units. What is the value of this and lambda? Here given the value of A vector, lambda I cap plus j cap plus 4k cap. The value of B vector, 2I cap plus 6j cap plus 3k cap. Also given the projection of A vector on B vector. The projection of this A vector on B vector is 4 units. The next step using the formula. In previous one we see the formula. The projection of A vector on B vector formula is A vector dot B vector divided by modulus B vector. So the value of A vector dot B vector divided by modulus B vector is given here 4. Therefore, A vector dot B vector divided by modulus B vector value is given here 4. Is your choice, we keep the denominator modulus B vector LHS or it goes in RHS also. It is your choice. So I will keep the term in RHS. So A vector dot B vector is equal to 4 into modulus B vector. Now you see the value of A vector. The value of A vector lambda I cap plus J cap plus 4 K cap dot B vector. The value of B vector 2 I cap plus 6 J cap plus 3 K cap over LHS is equal to 4 into modulus B vector. Modulus, it is a value of B vector 2 I cap plus 6 J cap plus 3 K cap. Now taking the dot product with the LHS. What is the coefficient of I cap in first vector? Lambda. Second vector 2. So lambda into 2 plus coefficient of J cap in the first vector 1. Coefficient of J cap in the second vector is 6 plus coefficient of K cap in the first vector is 4. Coefficient of K cap in the second vector is 3. Is equal to, already 4 is there. Now taking modulus, so square root of coefficient of I cap 2 square plus coefficient of J cap 6 square plus coefficient of K cap 3 whole square. What is the value of lambda into 2? Lambda into 2 is 2 lambda plus 6 ones are 6, 4 threes are 12 is equal to 4 into square root of 2 square 4, 6 square 36 plus 3 square is 9. So 2 lambda plus 6 plus 12 is 18 is equal to 4 within a square root. Sum of all term 4 plus 36 40 plus 9 is 49. You know very well the value of root 49 is exactly 7. So 2 lambda plus 18 is equal to 4 into 7. 2 lambda plus 18 is equal to 7 4s are 28. Plus 18 goes to RHS, so 2 lambda is equal to 28 minus 28. 28 minus 18, 28, the plus 18 becomes the side, minus 18 is 10. So the value of a lambda is 10 by 2. I cancel in the fifth table, second table, okay, 10 by 2. In second table, exactly the value of a lambda is 5. Directly we cancel the second table. The value of lambda is equal to 5. Okay students, today we will see some problems involving a modulus A vector plus B vector plus C vector the whole square, modulus sums, and also projection. The same model sum lies in example also. So you try the example sums, you must write each and every sum in your class note. The next question is, show that the points, there will be 3 points, 1, 2 and 3 are collinear. But we see along n vectors. In 10th standard you see how to find the 3 vectors are collinear. 3 points are collinear. Area of a triangle is equal to 0, then the given points are collinear. But you see here all are 3 dimensions. In 10th standard we see the 2 dimensions, that is x-axis, y-axis. Now we see x-axis, y-axis and z-axis, and also to prove the given sum by vector method. So the first step to convert the given points in vector. You know very well how to write. I will take the first vector is A vector, but the vector is not given, all in Cartesian form. How to convert in vector form? The first one is the coefficient of I cap, so 2 I cap. The next one is the coefficient of J cap, minus 1 is there, so minus J cap. The next one, coefficient of K, so 3 cap. We will take the second one is the value of B vector. So the value of B vector start from 4 I cap plus 3 J cap plus 1 into K is a K cap Next, C vector. 3i cap plus j cap plus 2k cap. So to prove any manner, to prove A vector, B vector, C vector form a triangle, and also to prove suppose area of a triangle is equal to 0, then the given points are collinear. I do one small work. Suppose the box product of this 3 vector is equal to 0. So again what is very easy. The box product of 3 vector is equal to 0 if I write the formula. Then the vectors A vector, B vector and C vector are collinear. It is also one method. This method is very easy. So we do this method. Box product of A vector, B vector, C vector is exactly 0. We come to the conclusion these 3 vectors are collinear. How to find the box products? The working rules are very easy. Box product of A vector, B vector, C vector is equal to, using this symbol. So this is a determinant. You know, in matrix and determinant symbol. What is the first vector? A vector, whose coefficient of I cap, j cap, k cap lies in the first row. Second vector coefficient lies in second row. Third vector coefficient lies in the third row. To find, suppose the value of this determinant is equal to 0, these 3 vectors are collinear. So box product ABC is equal to, what is the first vector? A vector. You check the coefficient of I cap, j cap, k cap. Coefficient of I cap 2, j cap minus 1 and k cap is 3. So 2 minus 1, 3. It lies in the first row. And what is the second vector? B vector. The value of B vector, 4i cap plus 3j cap plus k cap. So 4, 3, 1. Third vector is C vector. You see its coefficients 3, 1, 2. It lies in third row. 3, 1, 2. Now to find the value of this determinant. You remind how to find the determinant? In matrix and determinant you know very well. First 2 of, we leave the number 2 occurring row and column. We first multiply this 2. 3 2s are 6. We multiply this 2 number with a minus sign. So minus 1. Next, that will be put one minus sign. But here also one minus. So minus into minus is plus 1. We leave first row and second column. 4 2s are 8. Minus 3 1s are 3. So 8 minus 3. Plus 3 of, we leave the number 3 occurring row and column. 4 1s are 4. 3 3s are 9. We put one minus, so minus 9. So 2 of 6 minus 1, 5. Plus 1 of 8 minus 3, 5. Plus 3 of 4 minus 5, 9 is minus 5. Is 10. 5 minus 15. 15 minus 15. So box product of A vector, B vector, C vector is equal to 0. I already tell the working rule. Suppose the box product of this 3 vector is equal to 0, then these 3 vectors form an collinear. Now here also we prove box product of A vector, B vector, C vector is equal to 0. So what is the conclusion? Therefore, A vector, comma, B vector, comma, C vector are collinear. We remain again the determinant value. How to find the determinant? First, we will expand in row manner. 2 of, we leave the first row and second column. 3 2s are 6. Then we multiply this 2 number with a minus, and so minus 1. Plus, actually the symbol of the number minus 1 is a minus. Plus, minus, plus. So we put one minus. Here also one minus 1. So minus and minus is plus 1. We leave the number minus 1 occurring in row and column. So we leave first row and second column. Then we do the same one. 4 2s are 8. minus 3. Plus 3 of, we leave the number 3 again in row and column. 4 ones are 4, minus 3 3s are 9. Suppose this one is non-zero. This one is non-zero. The given vectors is not form a collinear. Therefore, A vector, B vector, C vector are collinear is enough. So the vector is not given, given only the points there. So we write one more line. That is, the given points are collinear. So the conclusion is also enough. A vector, B vector, C vector are collinear. Or suppose there is not a vector given, is a points. So then we write the given points is also collinear. But this stuff is enough. Or we write the given points are collinear also. So the given vectors are collinear or the given points are collinear.